Geoengineering. It's been called a catastrophe by the press, a surefire way to get ourselves into even more trouble with our current climate situation. It's been dubbed a government conspiracy by the internet, chemtrails that the government is using to mass medicate the population. And it's been hailed a quick fix for climate change by Donald Trump, another surefire example that chucking endless amounts of money at a few scientists will solve all of your problems. And it's resulted in claims like, give me half a tanker of iron and I will give you the next ice age. And despite, or maybe even because of all of this, geoengineering has its own program at Oxford University and has research funded by the Gates Foundation. So what is geoengineering and how can it be used to help New Zealand society are the questions I will be answering today. Geoengineering is the deliberate large-scale manipulation of the Earth's environmental processes in order to mitigate climate change. It incorporates aspects of all the sciences to do what humans have done for millennia and alter the Earth's natural processes in order to work in our favour. Just like adding fertiliser to the land to create more crops, or changing the course of rivers to generate electricity. The two most relevant examples of geoengineering to New Zealand are solar radiation management and oceanic fertilisation. Solar radiation management, or SRM, aims to reduce the amount of heat and light energy from the sun being absorbed by the Earth's atmosphere. Climate change is a result of atmospheric thickening caused by centuries of fossil fuel combustion in order to power our society. Solar radiation is subsequently trapped within the thickened atmosphere, causing the planet to heat up. SRM stops this from happening by increasing the planet's ablation, the amount of light and heat that is reflected back into space. The most common method of SRM is the injection of sulfate particles into the highest layer of the atmosphere. These sulfate particles act as tiny mirrors, deflecting heat away from the surface of the Earth and subsequently reducing the Earth's atmosphere temperature. The use of SRM is most commonly talked about in regards to restricting the average global temperature increase. The last time that carbon dioxide levels were as high as 400 parts per million as they are today, the Earth's global temperature was up to 8 degrees warmer. And we're on our way to reaching this target, as the International Panel for Climate Change has predicted a temperature increase of between 0.1 and 0.3 degrees Celsius per decade for the next century. Models have shown that SRM could effectively reduce this average global temperature increase to just 0.1 degrees Celsius per decade, which would make an immense difference in reducing the rate of sea level rise. As such, SRM is one of the most effective ways that we can mitigate climate change. SRM can be used as a critical intervention in the vicious cycle of ice loss, a cycle which is increasing the rate of sea level rise as I speak. Increased temperatures caused by climate change have resulted in a loss of ice, and subsequently a loss of material that reflects back solar radiation, therefore causing the Earth to warm further. I can confirm that if this cycle is allowed to perpetrate, i.e. if our Earth's global temperature rises by just another 4 degrees, my marine science department from the University of Otago will be underwater. But SRM could act as the brakes in this process by doing the job of the already melted ice and increasing the planet's ablation. SRM could also potentially benefit the health of New Zealanders too. By reducing the amount of harmful solar radiation reaching the surface of the Earth, it would theoretically reduce the rate of skin cancer, which affects 70,000 Kiwis every year. Skin cancer is caused by exposure to excess UV light, which of course comes from the sun and would hopefully be deflected through SRM. Correctly implemented, SRM would have massive positive ecological benefits. Species which are particularly affected by changing temperatures will have a more stable habitat to live in, and subsequently, the rate of species extinction should decrease. This would particularly affect New Zealand's ecosystems, which are governed largely by Antarctic weather patterns. We can use these ecosystems to our advantage when mitigating climate change. ocean fertilization is the addition of limiting metal nutrients into nutrient-deficient areas of the ocean in order to stimulate phytoplankton growth. The metal most commonly added in these scenarios is iron, because it's the most likely limiting nutrient for phytoplankton growth. Phytoplankton are microscopic plants, and like plants, they're fantastic at the process of photosynthesis, the conversion of carbon dioxide and water into glucose and oxygen. Subsequently, the carbon dioxide that's absorbed by phytoplankton is kept as either limestone or trapped in the food chain for a minimum of 100 years. The carbon dioxide that's absorbed by phytoplankton is kept out of the atmosphere and cannot contribute to climate change. In one experiment, over a 10 by 10 kilometre square patch of ocean, scientists added iron to slowly increase the natural concentrations of the surrounding seawater. What they found was a 40 times increase in the amount of chlorophyll produced. So as chlorophyll is created by phytoplankton and can be measured by satellites, it's used as a proxy for phytoplankton growth. The scientists calculated that the phytoplankton in their study had absorbed 100,000 kilograms of carbon. This is enough carbon fixation to offset the burning of 44,000 litres of petrol. This experiment demonstrates the tangible benefits of oceanic fertilization, as fixing carbon is one of the most important things that we can do for the environment. And ocean fertilization provides a cheap and potentially very effective way of doing so. New Zealand has the world's 4th largest economic exclusive zone. We're in the perfect position to be researching ocean fertilization. Moreover, ocean fertilization has been suggested as a method to increase the growth of fisheries, something that New Zealand's own highly depleted fish stocks could hugely benefit from. But if geoengineering is as good as I've sold it to be, why aren't we using it now? Well, there are 2 main reasons. The first is a major lack of public awareness, engagement, and communication with geoengineering. This has led to conspiracy theories such as chemtrails and other serious oppositions to scientific research. John Martin's flashy quote, "Give me half a tanker of iron and I'll give you the next ice age," seriously glosses over the major scientific planning and experiments that would be needed to make a large-scale geoengineering scheme work. However, the main reason why it hasn't been implemented yet is because scientists are unsure how to manage the potential side effects of geoengineering. There's a potential to alter the pH of rain as well as create dead zones in the ocean. More research is needed to be done before scientists can fully understand the large-scale implications of a geoengineering program. But what we do know is that our future goal of a sustainable environment cannot be achieved through geoengineering alone. Climate change, of course, is a massive problem which requires multifaceted solutions from a range of disciplines, from businesses to agriculture, urban planners, scientists, politicians, and even just the humble consumer. But we do need to investigate geoengineering as one of the potential options that could play a major role in stabilizing our environment. New Zealand, a country with the global reputation of being a leader in environmental protection, and a country which is going to be hugely affected by climate change within the near future, is in the perfect position to be researching and potentially implementing geoengineering. But what are the costs of these implementations? Well, the costs of geoengineering differ largely depending on who you talk to and how you plan to implement. Both the raw materials for ocean fertilization and solar radiation management are in themselves relatively inexpensive. However, for ocean fertilization, because the carbon dioxide uptake of the ocean is dependent on uncontrollable environmental factors, it's difficult to get a precise estimate for the cost per tonne of carbon dioxide fixed. Costings have put it anywhere between 47 New Zealand dollars and 200 New Zealand dollars just to fix 1 tonne of carbon. The most expensive part of SRM is the method of dispersal. It's been suggested that one way to scatter SRM particles would be to modify commercial aeroplanes. One estimate for the altercation of a Boeing 747 for this purpose has priced it at 35 million New Zealand dollars. Hopefully, with more effective research and implementation, this could become a lot cheaper. But are the costs of geoengineering greater than the cost of inaction in the face of global climate change? New Zealand is a country which relies heavily on its environment for its primary industries, agriculture and tourism, both of which are going to be heavily affected by climate change within the near future. All of our major cities are on the coastlines and are vulnerable to destruction from sea level rise. Imagine how much more exasperated Auckland's housing crisis is going to be if the sea level rises by 4 metres. Geoengineering is one of the ways that we can potentially mitigate this sea level rise and other climate change impacts. Climate change is the biggest threat that society will be facing within the next 50 years. It requires solutions that are going to work both in the long term and the short term. Undoubtedly, geoengineering is the ambulance at the bottom of the cliff approach to climate change. It has to be used in conjunction with other methods to reduce the impacts that our lifestyles are having on the environment. But the effects of sea level rise and climate change are already being felt, and the ground is rushing towards our feet. So wouldn't it be nice to at least have an ambulance? Thank you.
Are you suggesting that New Zealand could use geoengineering for New Zealand's purposes?
Yes.
Well, how would you distribute your sulfate particles so that they didn't whisk over to Australia?
That's a good question.
I thought it was.
You'd probably have to look at what the circulatory currents around New Zealand were doing at that time.
All right. How long would the particles last in the atmosphere?
That's a good question. I
Thank you.
don't actually know the answer.
If you reduce the sunlight through sulfate particles, would that not impact on the growth of plants?
It shouldn't do too much, but
And this is a technological fix for a problem caused by technology in the first place.
I wouldn't call it a techno fix, but yes, it's a problem caused by technology.
You wouldn't call geoengineering a techno fix?
Well, it's using technology to solve a problem, so I guess in that regards it is a techno fix. But lots of things around us are. It seems like that's a slightly negative term for very useful things that we use every day.
I was intrigued by your double-headed explanation as to why we're not using geoengineering now. First up, you said because people are uninformed.
Yes.
Well, the second point seemed to me perhaps to be given undue weight by you, which is that nobody knows how it's going to work.
Well, there needs to be research first before we can understand how it works, and people need to know what's happening for there to be research. So it's hard to convince people to fund something that they don't actually understand what it is or what it could potentially work for. So that's why we need awareness first, and then we need to explore the research.
And you presented it as a choice between geoengineering or doing nothing.
No, I'm saying that it would be a good thing to have, like an ambulance at the bottom of the cliff, because obviously these effects are already happening right now. Some people argue that there's nothing to be done about climate change, which I personally disagree with. But this could be something to offset the side effects that are occurring right now, like sea level rise around small island nations in the Pacific.
Thank you. Thanks, Grace.
Thanks.